Okay, factoring trinomials of the form ax squared plus bx plus c, where a is not equal to 1, meaning we're going to have a value here. So, review. Simplify x plus 2 times 3x plus 1. Show all four terms that FOIL would generate before simplifying. So remember, we get four products, right? So x times 3x is 3x squared. First, outer plus 1x. Inner plus 6x, and last plus 2. And what's that equal to? So 3x squared plus 7x plus 2. Let's complete this table, original form and factored form. And we're going to say, hey, we're factoring out a binomial, which is x plus 3. That's the greatest common factor, and we're left with x minus 2. Again, we have a binomial, m minus 1, and what's left? M plus 6. And a plus 6 is the common binomial, a plus 6, and 7a minus, what do we do here? Well, you imagine there's a 1 there because you do need something there, right? So minus 1. So that's a point to note. The common factoring shown in the table above will be useful when we factor trinomials of the form ax squared plus bx plus c by decomposition. Decomposition, which to me is boo-hiss. I don't like that method, but I will show it to you, and some of you will choose to use it, and it's the method of, here, we'll recompose the decomposition. So it's the method of decomposition. Not my preferred method, but certainly I'll show it to you so you can see how to do it. All right, so let's take a look. If we were to use algebra tiles, factor 2x squared plus 3x plus 1, so in order to use the tiles, that will represent the area of a rectangle. So let's draw this rectangle. So, what is it? So we got 1x squared, 2x squared. It doesn't really matter if I go down or across. I'm going to go across. So that's x squared, x squared. I've got to place 3 x's here. So if I put 1 here, and 1 here, I will leave a space. So there's 1x, 2x. Now the only other place to put this so that I can make a rectangle is there, and then I've got a 1. So we've got 2x squared plus 3x plus 1. And if we now look at the length of this, it's x, x, and 1, so that's 2x plus 1. And it's a binomial, and I bracket my binomials. And down here, we have x plus 1. And it's a binomial, and I like brackets. So the length is 2x plus 1, and the width is x plus 1. And area is length times width, which is 2x plus 1. Times x plus 1, and that is the factored form of 2x squared plus 3x plus 1. Factor 3x squared plus 7x plus 2. All right, so I need 3x squareds. Just imagine these two. So I'm going to put them in a row. Okay, 7x. So you know what? I think if I put like 3 x's here and another 3, right, that'll be 6x. So each of these guys is x. And then 1 off the end here. Then I have room for 2 1s, 1 and 1. So we have 3x squared, 1, 2, 3, 4, 5, 6, 7x plus 2, 1, 2, 3x plus 1, binomial, bracket it, x plus 2, binomial, bracket it, and the factored form is 3x plus 1 times x plus 2. Now, we don't always have a set of tiles with us. We are going to get much more complicated trinomials, so we have to do this without algebra tiles. And it's a little more complicated than factoring ones of the form x squared plus bx plus c. You're going to learn two different methods, one good, one bad. No, not that. Okay, just my judgment. There's one I like and one I don't, but you need to choose the method that works for you. Okay, that is the key. You find a method that works, you practice with that method, and you get good at it, and that's the method that you use. And if you find a different method somewhere else, feel free to use it as long as you get the fully factored form. Okay, so in order to get there, we're going to work our way through this little table here. We can see that the factored form, 12x squared plus 15 minus 8 is plus 7 minus 10. This will be 3x squared, and for those of us that want the plus 18x plus 1x plus 6, so the simplified form is 3x squared plus 19x plus 6. And here, 2x squared, so I'm just foiling it, right? Some of us might want to FOIL, plus 6x minus 5x, so some of us may choose to do it in our heads, minus 15. Okay, if you're doing it in your head, I just do it this way, 2x squared plus 6 minus 5 is plus 1x. I don't need to write the 1, minus 15. If you FOIL it, then we write it. Okay, and the important thing is just that we write this simplified form. Now, take a look at the a, b, and c values. So this a value, where does it come from? Well, you can see that it comes from the first in FOIL, right? And the same here, 3x times x is 3x squared, 2x times x. And if you take a look at the c value, you can see, well, here, a to f, c comes to last. Negative 2 times positive 5 is negative 10, and that's the only place that comes from, right? And we know this. We know this from the factoring that we did before. And the 7, the b value, comes from the outer and the inner, right? But collected together. So the 15x minus 8x, which is going to give us plus 7x. And we're going to use this. There ain't nothing else on that page. So, method number 2, right? That is after algebra tiles. Decomposition, breaking it up, or what did composers do? Like Beethoven, or they decompose. If you remember, in order to factor a polynomial of the form x squared plus bx plus c, we need to find two numbers that multiply to c and added to b, right? And again, I use a slightly different way of it, depending on whether c is positive or negative. I say they add to or they differ by. In order to factor by decomposition, you'll need to find two numbers that have a product with the same value of a and c and a sum, I'm going to say, or difference of b. So, factor 3x squared plus 7x plus 2 using decomposition, right? So here, nice set of notes on decomposition. We're going to very much break this up, okay? And you're going to look at the method and figure out what's going on. And we're going to do a couple of these, and then you can practice if you like, if you choose to use this method. So, you should always look for a common factor first. 3, 7, 2. No, there's no letter in common, so there is no GCF. You now need to find two numbers that multiply to 3 times 2. So they multiply to be 6. And since this is positive, they're going to add up to 7. So what two numbers multiply to 6 and add to 7? 6 and 1. The next step is to break up or decompose the middle term into two separate terms using these two numbers. It's like doing the reverse step of simplifying. We're going to make it into the four terms that would be generated by FOIL. So here's the first step. So we get 3x squared plus 7x plus 2 becomes 3x squared plus x plus 6x plus 2. So we've split it up into four terms, just like FOIL. We're going to factor by grouping the first two terms and the last two terms. And what that means is we're going to take the first term and first two terms, we're going to factor them. And we say, okay, the GCF is x, and I'm left with 3x plus 1 plus this plus sign. The greatest common factor here is 2, and I'm left with 3x plus 1. And the idea is that this must be the same as this. It needs to be a common factor, and that's what we're going to do now. We're going to common factor. In this case, it's a common binomial factor, right, which is 3x plus 1 and leaves us with x plus 2, and that's the factored form of this. Now you might say, well, what if I wrote 3x squared plus 6x plus x plus 2? Because you're going to say, well, you just told me I got to break the middle term, the 7, into a 6 and a 1, but I could do it this way. And I would say, okay, I'd like to throw some equal signs in here. So I would say, well, the greatest common factor here is 3x, and I get x plus 2. And the greatest common factor here is 1, giving me x plus 2. And so what we're looking for is, remember, I want to find a GCF of x plus 2 here. And I just have x plus 2, so we're going to write it as 1 times x plus 2. So now the greatest common factor is x plus 2, and what's left? 3x plus 1. And you'll notice that these two are the same. They're just written in a different order. Okay, which is fine because we have the fully factored form. How do we know? Okay, there's no common factor here, no common factor here. So that is the method of decomposition. Does it matter? Now you get to choose, right? So that's the thing. You can choose. So if you recognize, hey, I can get a common factor of 3x out of this, you know, and then get this x plus 2, that's fine. Or you could say, I get a common factor of x out of this. Either way, it's going to factor down properly. So let's try 2x squared plus 3x minus 20 using decomposition. So the first step, is there greatest common factor? No, nothing, you know, because we got 2 and 3 are prime. There's no variable the same, so no GCF, right? Always the first step is greatest common factor. We need to find two numbers that multiply to 40. Now, here's how I'm going to say it. They multiply to 40, and they, since this is negative, they differ by 3. So the two numbers that do that are 8 and 5. 8 times 5 is 40, and 8 minus 5 is 3. Now, here's how we're going to do it, right? Decomposition. So we're going to go 2x squared. Now, if I need a plus 3x, so I'm going to go plus 8x minus 5x, right? Because I know that really they're multiplying to negative 40 and adding to positive 3, right? But I like to say multiply just to 40. I'm not worried about the signs. I'll worry about the signs down here. So I say, well, 8 and 5 are my numbers. To get a positive 3, it's going to be plus 8x minus 5x, and then minus 20. Factor by grouping. So this factor is 2x, giving me x plus 4. Now, here's the thing. I need an x plus 4, right? You have to have that. And what do I take out here? It'll be minus 5, right? Minus 5x minus 20. Just watch and see that you can rebuild the original, right? 2x squared plus 8x minus 5x minus 20. So everything's good. Common factor, x plus 4. And 2x minus 5, it's what's left. I generally will write the 2x term first, so 2x minus 5, and then the x plus 4 term. Now, you might say, well, what if you did it in the other order, right? What if I go 2x squared minus 5x plus 8x minus 20? Now you can see, well, you're in for a little bit of pain here, in a sense, but you're still going to get the same answer. It's not going to matter. It's just, hey, this is nicer because 2 goes into 8. But here, our common factor is x, leaving me with 2x minus 5. This one is plus 4. 4 goes into that, leaving me with 2x minus 5. And then. So still the same answer. Doesn't really matter. Your choice. Okay, and again, it's just practice, 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 practice. Is there a common factor? Well, they're all even, so 2 goes into them. Okay, so let's take a 2 out. We'll get 4n squared minus 9n plus 2. Check that out. 8n squared minus 18n plus 4. Since it's a polynomial of the form, we need to find two numbers that multiply to 8. This is positive, and they're going to add to 9. Okay, so they're going to add. It's just they're both going to be negative. So the numbers are 8 and 1. So decomposition. Oops, hang on. Let me just put that back up there. So we have our 2, right? And then we have our bracket. And inside the bracket, I'm going to write this, 4n squared minus 8n. And I'll do that because, 4 and 8 share a common factor of 4 and then the n. Minus n, right? Because I know these two numbers, the 8 and the 1, both have to be negative. It's the only way we're going to get a negative 9n. But at the same time, we need that positive 8, right? And, the only way you get the two numbers here to get to be minus 9n is if they're both negative. And then plus 2. The 2 is the common factor that's out in front. Okay, so I'm now going to factor 4n, and this will be n minus 2. Now, here's the deal. I need an n minus 2, and I'm looking at kind of this n plus 2, so I'm going to put minus, right? And putting a minus changes the sign of both of these terms, right? So that the n, which was negative, becomes positive, and the plus 2 becomes minus 2. And more importantly, this is now my common factor. So it's equal to 2, n minus 2, and 4n minus, right? And there's nothing here, right, but that's a 1. So there's not nothing there. There's a 1 there. And when I go to write this out in completely factored form, I'm going to go 2, 4n minus 1. And that's just because I like my bigger number term here, and then n minus 2. Remember, you can check to see if the factored form is correct by simplifying it and make sure it matches the factored form of the polynomial you start with. Right? In other words, we can multiply this out. So it's 2 times, okay, and we'll use FOIL. So we'll get 4n squared minus 8n minus 1n plus 2, right? 4n squared minus 8n minus 1n plus 2. So that's 4n squared minus 9n. So before we multiply, we're going to collect terms. You don't need a 1 there. Plus 2, which is 8n squared minus 18n plus 4, which is this. So that checks, right? So, and is it fully factored? Yes, there's no common factors here. If you had forgotten to take out the 2 as a common factor, you would have ended up with a factor of like 2n minus 4 or 8n minus 2, and you would have had to realize, oh, wait, I can still take a common factor out, and you would have had to do so to make sure it's in fully factored form. And when we say factor, we mean fully factored form. Okay, is there a common factor? No. Since it's a polynomial, we need to find two numbers that multiply to 10. And since it's positive, they both have to be negative, and they're going to add to negative 1. Right? Or actually, I just say they add to 1, and then I just make sure that, that when I decompose, I'll get a negative 1. So, well, 1 times 10, that adds to 11. 2 times 5 goes to 7. And there's no other way to break up 10, right? And really a really important skill in factoring is just being able to break up a number into its two-number products or factors, right? So what problem do you run into? We can't find the two numbers. So what do? So this is not factorable.
Yeah. Okay, all right, right.
Can all trinomials be factored? No, just like the other form. So not everything is factorable. How do you know if it's factorable? So there will be a number, or two numbers that multiply to give you a times c, and add to or differ by b, right, the middle number. So I'll give another two examples of trinomials that cannot be factored. I don't know, let's go 3x squared plus 7x plus 1. I need two numbers that multiply to 3 and add to 7. Not going to happen. And 2x squared plus 4x minus 3. How about that? So two numbers that multiply to 6 and differ by 4. Okay, what multiplies to 6? 1 and 6, 2 and 3. Can't get a 4 out of that any way, shape, or form. Write a number so that it can be factored. Okay, so I need two numbers that multiply whatever I'm going to put in here and then add to 5. So, all right, what can I put in there? So if I put an 8, that will give me 24. No. How about, so two numbers, let's just two numbers that add to 5. How about 4 and 1 add to 5, and their product is 4. Well, I can't find anything here. 2 and 3 add to 5, and their product is 6. So if I put a 2 in there, I need two numbers that multiply to 6, add to 5. They are 2 and 3. So 3x squared plus 3x plus 2x plus 2. 3x is the common factor, giving you x plus 1, and 2 is the common factor. And remember, we need this common binomial factor, and I need to extend the page a little. And that's equal to x plus 1 and 3x plus 2. So I need two numbers that, okay, since that's negative, they need to differ by 4 and multiply to, well, whatever I'm going to put in here. So like if I put a 2 in here, that would be 10. Need two numbers that multiply to 10 and differ by 4. 1 and 10, 2 and 5, not going to do it. If I put a 3 in here, that would be 15. 1 and 15, 3 and 5, don't differ by 4. If I put a 4 in here, I get 20. 1 and 20, 2 and 10, 4 and 5, none of those differ by 4. If I put a 5 in here, I get 25. Well, no, won't differ by 4. If I put a 6 in here, I get 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. No, don't differ by 4. If I put a 7 in here, it's like, oh my god, how far do I have to go? Put a 7 in here, I get 35. I put an 8 in here, I get 40. I got to start writing them out. 1 and 40, 2 and 20, 4 and 10, 5 and 8. No, put a 9 in here, 45, 1 and 45, 3 and 15, 5 and 9. Oh my god, we found it. So if I put a 9 in here, 9x squared, the two numbers will be 5 and 9. So we'll go plus 9x minus 5x, right? I know they're opposite signs because they really have to multiply to negative 45. That's why I said differ by. These numbers differ, right? So it's not 9 plus 5, it's 9 minus 5. And then we've got the minus 5. So 9x, giving me x plus 1, minus 5, and that's going to change the signs, right? And we need these to be the same. So minus 5x minus 5, you check it out. And we get 9x minus 5, and x plus 1 equals, 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 equals. And now we come to my favorite method, trial and error, aka guess and check. And I'm going to need to pause a bit here because we're at the class change, and then I will finish this off. So pause. Okay, so method number 3, trial and error, or as I like to call it, guess and check. Now it's not as systematic, but once you get the hang of it, it can be very efficient. Watch your teacher, put a little separator there, watch your teacher explain how. Okay, so here's how we do it. Looking at this, I say, my first is going to give me, so what I do is I write down 2 sets of brackets. Since they're both pluses, I want to get a 3x squared. The only way that's going to happen is with 3x and x, right? That's what's going to give me 3x squared. Since this is positive, the two numbers have to have the same sign. And since this is positive, they both have to be pluses. So I can put a plus and a plus. I need two numbers that multiply to 2. And I need to get a 7. If I put a 2 here and a 1 here, let me just do that, 2 and 1. I'll get 3x squared plus 3 plus 2, which is 5 plus 2. So I need the 1 and the 2, but I need them in different places so that this becomes 1. So the way I think of it is I need 3 times 2, that'll give me 6, and the 1 will give me 7, and check, right? Trial and error. Well, hopefully maybe no errors. So 3x squared plus 6x plus 1x is plus 7x plus 2, and I'm done, right? That's all I have to show. This one, now, okay, we got a slightly different problem. When this number is prime, the only way you're getting 3x squared is to have a 3x and an x. To get a 6x squared, you could have 6x and x, or you could have 3x and 2x. Right, so really what we're doing is saying we break up the 6. It's either 1 times 6 or it's 2 times 3. Now, the last number we know is going to give us negative 2. It means I need one positive, one negative. They have to add to 2, or sorry, they have to multiply to 2. And then the product, the outer inner, has to differ by 1. So if I put a 2 here and a 1 here, I'm going to get a 12 and a 1. And 12 and 1 will add to 13, or they'll differ by 11. If I put the 2 here and the 1 here, I'm going to get 6 and 2. And there's no way to get a 1 out of that. So I am going to put the 2 here and the 1 here. That will give me 6x squared, 3x, and then 4x. So I want it to be plus 4x minus 3x. So 6x squared minus 3x plus 4x is plus 1x minus 2. So it's going to be a 3x and a 2x. It's going to be, so to get the 6x squared again, it's going to be 3x times 2x, which will give me 6x squared. To get the minus 2, it's 2 times negative 1 gives me the minus 2. And then what I need to watch for is, well, what are my middle terms going to be? And in this case, minus 3 plus 4, which gives me the plus 1. And really what we have to watch out for in this is that we don't go 3x minus 2 and 2x plus 1, right? Because we're saying, well, that gives me 6x squared and that gives me minus 2. But we get 6x squared plus 3x minus 4x, which is minus 1x, right? And we don't want that. So for sure we have checking going on, right? We need to find the numbers and we need to check. This one, everybody's got an a, so we're going to take an a out, giving me 2n squared minus n minus 15. This is one of the easy ones, actually, for guess and check, right? Because we know we're going to have a 2n and an n. That's the only way to get 2n squared. Now, 15. It could be 1 and 15, right? But how do you combine 1 and 15 with 2 and 1 to give you, a negative? It's not going to happen, right? So it's going to be a 5 and a 3. And if I put the 3 here, I'm going to get a 6. And I put the 5 here, I'm going to get a 5. I want minus 6 plus 5, right? I know these are opposite signs because I've got negative 15. So 2n squared minus 6n plus 5n minus 15. Now, let me show you a little more systematic way. Let's go back to this one here. So I need numbers that multiply to 6, right? And I say it's either 1 and 6 or 2 and 3. And I need numbers that multiply to 2. And the only numbers are 1 and 2. And so I'm saying, how can I combine 1 and 6 with 1 and 2? So I can multiply this way. This gives me a 12 and a 1. 12 and 1 will add to 13, and they'll differ by 11. right? So out of 12 and 1, you can either get a 13 or an 11. And I want a 1, so that won't work. So let's go the other way. Let's multiply, whoops, cleared out the 1. Let's multiply 6 times 1 and 1 times 2. That gives me 6 and 2. Well, out of 6 and 2, I can get 8 or 4, right? 6 plus 2 will give you 8. 6 minus 2 will give you 4. Not going to work here. Let's clean that up. Right, so that's not the numbers we're going to use, right? We're not using 1 and 6. As a matter of fact, here, let's wipe everything out. Clean, 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 clean. And clean this up. Okay, so 2 and 3 with 1 and 2. So if we multiply this way, 3 times 2 and 2 times 1, this gives me 6 and 2. 6 and 2 give me an 8 or a 4. So that doesn't work. Okay, so how about this? This gives me 4. 2 times 2 is 4. 3 times 1 is 3. 4 and 3 can give me a 7 or a 1. And you say, hey, I want a 1. Okay, so now we say, I know that it's 2x and 3x, right? These are your leading numbers. The 3 has to multiply, well, let's do it this way. The 2 has to multiply the 2, and you don't multiply what you're in with, so the 2 has to multiply the 2. The 3 has to multiply the 1. I want a positive, so my outer and inner will be 4 and 3. I need plus 4 minus 3. 6x squared plus 4x minus 3x is plus 1x minus 2. Done. Okay, we're done. Okay, so it's harder when it's a composite number leading. It's easy when it's a prime number because this has to be 3x and x. This has to be 2n and n. It's the only way to get 3x squared or 2n squared. Completely factor each of the following trinomials. Remember to look for a common factor first. Okay, so what I'm going to do, and again, this is a video-only bonus, which is going to be me factoring this, and I'll show you the way that I factor. I'm just doing this by guess and check. You can do them all by decomposition, and I'm just going to kind of buzz through them reasonably quickly. They're up. It's up on the video for you to watch if you're having problems with the exercises. Okay, completely factor each of the following polynomials. Look for so here we have a common factor of 2, right? So it's 2x squared minus x minus 15. So I may immediately put down a bracket with a 2x in it and another set of brackets with an x. Now I need two numbers. They're going to multiply to 15, and what do they do? I'm going to get a 1. I'm thinking 3 and 5, right? So I think 2 times 3 is 6, and 1 times 5 is 5. I need minus 6 and plus 5. 2x squared minus 6x plus 5x is minus 1x minus 15. Done. Okay, hey, it's either 1 and 8 or 2 and 4. I'm going to go with, okay, and remember, this method is guess. I'm going with 4 and 2. The two numbers here are going to multiply to 3, so that's pretty easy. It's 3 and 1. If I put a 3 here, I'll get a 12 and a 2. That won't give me 2. Let's put a 3 here and a 1 here. 8y squared. This is 4y and 6y. Well, I need plus 6y minus 4y. 8y squared minus 4y plus 6y is plus 2y minus 3. Done. No common factor. I'm guessing 9 and 3 is probably 3. And what I often find is it's usually not the extremes, like 1 and 8 or 1 and 9. Multiply to 4, so it really doesn't matter where I put the 4 and the 1. They're both positive. So 9p squared plus 12p plus 1p is plus 13p. Okay, not that. Let's try 9p and p. I don't want the 4 here. That'll give me a 36. So I'm going to put the 1 there and the 4 there. And that's not going to work because that'll give me 9p squared, or sorry, 9p squared plus, they'll both be pluses. 9p squared plus 9p plus 4p is, whatchamacallit? No, 13. Okay, so that's not it. Now wait a sec. Let's go back to 3 and 3. there are more numbers that multiply to 4 than 4 and 1. So what if we go 3p plus 2 and 3p plus 2? 9p squared plus 6p plus another 6p is plus 12p plus 4, and there we go. Okay, 6. So I'm going to start with 2r and 3r. Multiply to 10. So if I do 5 and 2, that'll give me a 10 and a 6. If I do 5 here, 15 and 4. No, 1 and 10. So what I'm doing is just playing with the numbers that are going to multiply to 10. And you know what? I don't think I'm going to find any. So I'm going to go with 6r and r. So if I put a 2 here, I'll get a 12, and a 5 here, I'll get a 5. I need to have, so we'll get 12. Let's go with plus 12 minus 5. 6r squared plus 12r minus 5r is plus 7r minus 10. Done. Common factor, 2. 12x squared minus 5x minus 2. 12. Wow, 12. Right? Okay. You know what? I'm going to do a little bit of playing first with numbers. I can do this down here. This will be my scrap paper. So 12. 12 can be 1 and 12, or 2 and 6, or 3 and 4. And 2, well, that's just 1 and 2. So 24 and 1. Remember, I'm looking for 5. Because that's a minus. I'm looking for numbers that differ by 5. 12 and 2, no. So 12 and 2, no. 6 and 4, no. 8 and 3. 8 and 3 are going to do it. So we're going to have a 4x and a 3x. The 4 has to multiply the 2, putting this here. That'll be a minus, and then we've got a plus 1. Okay, let's try it. 12x squared. Minus 8x plus 3x is minus 5x minus 2. Done. 6a. All right, let's go 2a, 3a, and 4. Well, 4 can be 1 and 4. Okay, this is a plus, this is a minus. Tells me they're both negative. So if I go minus 4 minus 1, we get 6a squared. Minus 8a minus 3a is minus 11a plus 4 equals, done. Erase. 20. Well, 20 is divisible. These are all divisible by 10. So 2x squared. I like 2's, right? 2's are easy. Plus 7x plus 6. Because I know it's a 2x and an x. Even if you like decomposition, 2's are easy. Okay, I want to get a 7. Everything's positive, right? So if I put a 6 and a 1, I'll get a 12. I put a 1 and a 6, I'll get an 8. So it's going to be a 3 and a 2. Let's put a 2 here and a 3 here. That's plus, that's plus. 2x squared plus 4 plus 3 is plus 7x plus 6. Done. 3 goes in all of these, so it would be 3. And we'll get 6y squared minus 4y minus 5, right? So that's done. Check it. 18 minus 12 minus 15. I'm going with 3y and 2y. Two numbers that multiply to 5, so if I put a 5 there, that'll give me a 15. I put a 5 there, I'll get a 10, and a 1 here, right? These numbers are 5 and 1, right? There is no choice. It's 5 here, which gives me 15 and 2, but I can't get a 4 out of that. If I put a 5 here and a 1 there, I'll get a 10 and 3, so that one. Okay, so let's go to 6y, and just plain y. Okay, 5 and 1. If I put a 5 here, I get a 30, so it's got to be a 1 here and a 5 here. No. All right. Things are not looking good. So let's double check. 18y squared minus 12y minus 15. Well, guess and check's not doing it for me, so let's go to decomposition. I never thought I'd see the day. So I need two numbers that multiply to 30, and because of the minus sign, they differ by 4. Okay, 1 and 30. 2 and 15, 3 and 10, 6 and 5. There are no numbers that differ by 4 here. So I do not believe that this can be factored. Give all values of k such that 4x squared plus kx plus 3 is factorable. Okay, let's do the whole decomposition route. I need two numbers that multiply to 12, and since that's a plus, they add to k, right? And k could be positive or k could be negative, but numbers that multiply to 12, 1 and 12, 2 and 6, 3 and 4. These add to 13, these add to 8, these add to 7, so those are the values of k. If I put a plus 13, so 4x squared plus 13x plus 3, 4x squared minus 13x plus 3, right? And so on. You can do a plus or minus 8. You can do a plus or minus 7, right? What are your factorizations? It's going to be a 4 and an x, a 4x and an x, and then a 3 and a 1. So to get 13 plus 3 plus 1, 4x squared, plus 12 plus 1 is plus 13x plus 3. And if you want the negative, then it's 4x minus 1, x minus 3, 4x squared, minus 12, minus 1 is minus 13x plus 3 again. And the same logic will work in doing these. So your numbers are plus or minus 13, plus or minus 8, plus or minus 7, and really it's just finding these pairs. Poster has a picture that is surrounded by a border. The poster has an area that can be represented by 6x squared minus 19x. That's the whole area. If the border is a width equal of 2 all around, then determine an expression for the area of the picture. So we basically need to find the length and the width, which says we need to factor 6x squared minus 19x plus 15. And I hope we have better luck with this one. So I'm going to try 2x and 3x. Need numbers. This is a plus. They'll both be minuses, right, to get this minus number in the middle. They're going to multiply to 15. If I put a 5 there and a 3 there, I get 6x squared minus 10 minus 9, which is minus 19x plus 15. So this is in fact 2x minus 3, and this is 3x minus 5. If the border is a width of 2, then we're going to have to subtract 4, and that'll make this 2x minus 7. And again, we got 2 here and 2 here, which we're subtracting from that. This will be 3x minus 9. And an expression for that is 6x squared minus 18 minus 21, which is minus 39x plus 63. And that is an expression for the area of the picture itself. And that is done. And if I find something that this factors with, I will come back and make a change. Otherwise, this is not factorable, which is my immediate judgment. So that's what we're putting in there. Done. And that's the exercises. That's your video bonus.